Welcome to the deep dive. You know how it is. You grab a jar of honey off the supermarket shelf, maybe drizzle it on some toast, and you barely give it a moment's thought. But what does it actually take? I mean, to run an operation that deals in millions of bees, producing, well, a literal empire of liquid gold. Today, we're going far beyond the hobbyist beekeeper.
That's absolutely right. Our sources take us deep into the machinery required for commercial apiculture, really at the highest level. We're zeroing in on IG and Honey Farm. They're the largest bee farm in the U.S., and we want to reveal the sheer scale, the intense logistics, and the near-pharmaceutical precision involved.
And the scale is just... It's hard to wrap your head around. Aided Honey Farm started in South Dakota, back in 1957? It's just ballooned from maybe 1,500 hives then to maintaining over 80,000 active colonies today.
Exactly. And that kind of coordination, it's necessary to produce their typical annual yield. We're talking about 1 million liters of honey. That number alone tells you this isn't just farming in the, traditional sense. It's a highly coordinated logistical machine. And it's dedicated not just to honey, but also to producing that really prized royal jelly.
Okay, let's unpack this monumental effort, starting with the logistics of, literally moving an insect army across the country. They call it nomadic beekeeping.
Yeah.
Why? Why can't 80,000 colonies just stay put?
Well, they can't, primarily because a huge chunk of their revenue actually comes from pollination contracts. Yes, they need to chase the bloom for a continuous nectar flow for honey, but they're also essential workers for specific high-value crops.
Okay, give us an example of that movement. What does the schedule look like?
So the sources show they start in California, usually around February.
California?
Wow.
Why there?
Almonds. That's when the almond orchards bloom. Aid Honey Farm basically rents out its bees. It ensures the almonds get successfully pollinated, and as a kind of bonus, the bees collect valuable almond nectar. After that critical period, they transition back towards the Midwest through the growing season, hitting various blooms, securing diversity in their honey types.
That must require massive coordination.
Yeah.
Moving 80,000 delicate colonies via specialized trucks across state lines. What's the risk versus reward on that kind of transport?
Oh, the risk is enormous. I mean, losing hives from overheating or accidents, that's an immediate blow to revenue, both from honey production and those pollination fees. The reward, though, is diversification and keeping productivity going almost year-round. It's a trade-off, but one that demands highly customized equipment and timing precision that really borders on military logistics.
And the hives themselves, they can't just be simple boxes, right? They're engineered tools designed for survival on the road. What makes a commercial hive capable of handling this nomadic life?
The structure is absolutely everything. They usually rely on pine or white cedar. And what's fascinating here isn't just longevity. These woods are actually excellent heat insulators. Think about it, you're moving 80,000 temperature-sensitive units across different climates. Maintaining thermal stability inside that hive, especially during transport, is just crucial for colony survival.
So the outside is tough. What about the inside, the internal architecture that enables this industrial scale?
Well, the structure is tiered. You've got a base, then the brood box, that's the main living area where the queen lays her eggs. And then you have multiple honey boxes, they call them supers, stacked high above it. That separation is really key to maximizing the honey yield without disrupting the core colony life. And the whole thing is capped off with an insulated lid, protection from rain, cold, you name it.
And inside those boxes, you have the precision components, the frames.
Exactly. These rectangular wooden frames hold what they call wax foundations. These are basically the blueprints for the bees. They guide the bees to build those perfectly structured hexagonal cells, ensuring uniformity. Beekeepers use either pure beeswax or sometimes wax-coated plastic foundations.
Does using plastic foundations affect the final product at all?
Well, some commercial operations prefer the standardization and, frankly, the durability of plastic. Though, many beekeepers still champion natural wax. They argue it improves bee comfort and maybe the overall purity of the final product. But regardless of the material, customization is common. While specialized factories often churn these parts out, some big U.S. farms actually build their own.
To save costs, or?
Yeah, to save costs, or maybe to fine-tune dimensions based on their unique local climate needs. The only hard rules are use non-toxic exterior paint, and the interior must never be painted to protect both the bees and the honey.
The engineering sounds incredibly precise, but so is the daily care, right? Keeping 80,000 colonies healthy must be an unending task.
Oh, it's continuous oversight. It starts in early spring. Beekeepers are constantly checking queen health, assessing their stores, making sure they have enough honey, pollen, nectar reserves. But probably the greatest strategic threat they're always monitoring for is the Varroa parasite.
The scourge of the honeybee population worldwide. I've heard about those.
It is a massive, multi-million-dollar problem for the industry. Yeah. Varroa mites are these external parasites. They attack and feed on honeybees, transmitting viruses. They just weaken the entire colony. Dealing with them requires sophisticated, specialized knowledge. Biological treatments, chemical treatments. This isn't just basic pest control. The timing and the type of treatment are critical. If you choose the wrong method or treat too late, you could wipe out thousands of hives.
Turning that million-liter yield into an economic disaster.
Exactly. It puts the pressure on.
Yeah. That really puts the labor of the beekeeper into perspective. Okay, let's talk about the payoff. The harvest. This is where the sheer productivity of the worker bee just shines. You have to appreciate the stats here. These tiny creatures flying over 20 miles per hour, visiting up to 2,000 flowers daily, and collectively contributing over $175 million annually to the American economy, just through pollination and products.
It's an astonishing labor output, truly, and harvesting this golden product requires a process that, well, respects that effort. It demands patience and skill, even at this industrial scale.
So how do they manage it, collecting frames without triggering, defensive chaos across 80,000 hives?
It's an ancient technique, actually, and highly effective. Smoke. They use a gentle thread of cool smoke, typically from dry wood bark or other natural materials, and it's directed carefully toward the hive entrance.
Why does that work? Is it like an anesthetic or something?
Not exactly an anesthetic. The smoke triggers a natural instinct in the bees. They think, potential forest fire. So they start gorging themselves on honey, preparing to evacuate if needed. A full bee is generally a calmer bee. Plus, the smoke temporarily disrupts the pheromones they use to communicate danger. It encourages them to retreat naturally, harmlessly, usually down to the bottom of the hive.
So it's like a peaceful eviction notice, allowing the beekeeper to access the honey supers without massive aggression.
Precisely. The frames are removed carefully. Any remaining bees, any stragglers are gently brushed off with a soft brush. And crucially, they never take everything. Enough honey must be left. It feeds the colony through winter, prepares them for the crucial next season. So despite all the machinery that comes later, this on-site management, the perfect timing, it's entirely reliant on human expertise.
Okay, so once those capped frames leave the field, they start their journey through the factory. Let's follow that path, starting with preparation.
Right. The first step is warming. The barrels are containers of honey. They're stored and warmed, but at a very precise, narrow temperature window, usually between 37 degrees C and 40 degrees C. That's about 98 to 104 Fahrenheit.
Why so precise? What happens if they get the temperature wrong?
Well, if it's too low, the honey stays thick, highly viscous, makes extraction really inefficient, slow. But if it's too high, even just slightly above 40 degrees C, you risk damaging the honey's delicate natural aroma, its color, and reducing its nutritional integrity. So this gentle warming just reduces viscosity, helps it flow without compromising the quality.
Got it. Next, the capping is removed.
Yep, high-speed rotary blades shear off that thin layer of wax capping from the cells. But here's a neat efficiency part that wax is valuable itself. It's immediately filtered and fully recycled, goes into high-value products like cosmetics, candles, even new wax foundations. It's basically a zero-waste process there.
Okay, smart. Then comes the extraction phase.
The uncapped frames are loaded into a centrifuge. This machine spins at extremely high speeds. It uses centrifugal force to essentially throw the liquid honey out of the cells. The genius here is that the underlying wax structure, the comb, stays intact. Those frames can then be immediately returned to the hive for the bees to reuse. That's a massive economic and time-saving efficiency booster.
After the spin, you've got your raw liquid honey. Is that ready for bottling then?
Almost. But it's not quite clear enough for what consumers expect on the shelf. It still contains micro-impurities, tiny fragments of wax, maybe some fine dust picked up during transport or processing. So it undergoes a two-step filtration. Coarse filtration first, then fine filtration. That removes those minute particles, guaranteeing what the industry calls ideal clarity.
And finally, the journey to the jar.
Right. The filtered honey is moved to large blending tanks. There, it's gently stirred. This ensures perfect flavor and color consistency across these massive batches. Then it hits the automated bottling lines. These systems use advanced sensors to adjust quantities precisely, making sure every bottle meets the required weight with virtually zero waste. It's an incredibly tight, efficient operation focused on product uniformity.
Okay, now we need to shift gears a bit.
Okay.
From the million-liter product honey to this hidden treasure, that requires even more complex logistics. You called it the crown jewel of the hive, royal jelly.
Royal jelly, or RJ, yeah. It's fascinating stuff. It's the exclusive food source for the queen bee. And that's why she lives so much longer, exponentially longer, and is significantly larger than the worker bees. It's rare, and because of that, it commands a real premium.
What's actually in it that makes it so potent?
It has a unique and really complex profile, high concentrations of proteins, specific amino acids, vitamins, minerals, enzymes, the works. Its value in the supplement world, it largely comes from its ability to boost the immune system. And that's attributed to high levels of specific antibacterial and anti-inflammatory proteins.
Okay, so here's where we get to the really ingenious part, right?
Yeah.
The deception required for large-scale RJ collection. RJ is produced by worker bees, but you need them to mass produce it. How do you trick 50,000 workers into thinking they need to raise hundreds of queens?
That's exactly the strategic move. RJ is secreted by the worker bees, and remember, a colony can have 50,000 to 80,000 of them. It's not made by the queen. So the beekeeper temporarily removes the natural queen from the hive. This creates a sense of emergency, queenlessness. Then they insert very young larvae that have to be less than 3 days old into specialized artificial cup cells. These perfectly mimic the structure of natural queen cells.
Ah, so the workers see these cup cells with young larvae inside, and they instantly assume, okay, we need to prepare new monarchs.
Exactly. They're essentially deceived into believing the hive is queenless and they need new queens, fast. So they begin rapidly secreting large quantities of royal jelly to feed these potential monarchs. The labor intensity involved here is just staggering. You might have 10 to 12 worker bees tending to a single larva. They could be working 10, 12 hours a day, covering several kilometers, just in the process of producing this RJ.
And despite all that incredible effort, the yield is minuscule, which explains why it's so expensive.
It is incredibly small per cell. We're talking only about 0.1 to 0.2 grams collected per cell. And the timing is absolutely critical. RJ quality peaks after exactly 3 days of feeding. If you wait longer, the quality starts to deteriorate rapidly. So at that precise moment, the larvae are carefully removed. They're not used in the final product, by the way. And the RJ is extracted very quickly using specialized tools like tiny suction pumps to ensure zero contamination.
Wow. Because once that royal jelly is out, it's extraordinarily sensitive, isn't it? Which pushes the preservation and purification standards into, like, the pharmaceutical realm.
Yeah, absolutely. Its sensitivity to light and heat is severe. Any exposure causes rapid oxidation, and that just degrades its nutritional value, basically ruins the product. Therefore, it must be cooled immediately upon collection, right away.
What are the storage standards, then, to protect these delicate proteins?
They're very strict and depend on the intended shelf life. For short-term storage, maybe up to 6 months, it has to be kept between 0 degrees C and 5 degrees C, just above freezing. For longer-term storage, say up to 1 or 2 years, it needs to be deep frozen. Temperatures between -18 degrees C and -20 degrees C, that's below 0 Fahrenheit, and always stored in dark or opaque containers. Shield it from any light exposure. Even thawing has to be gradual, usually done slowly in a refrigerator to maintain that protein integrity.
And before it even gets packaged, it undergoes rigorous factory testing. What is quality control looking for in something this specific?
They conduct really stringent tests, checking color, taste, purity, but also detailed chemical analysis, looking at specific properties like moisture content, key protein levels, and they also do detailed microbiological analysis to make absolutely sure the product is free from any contaminants.
And even with careful collection, the raw liquid probably contains some impurities.
It does, inevitably. Small wax fragments, maybe some cell residue. So it requires fine filtering to remove those impurities. Occasionally, very low heat pasteurization might be employed to eliminate bacteria. But the temperature control has to be exceptionally precise because, like we said, excessive heat instantly ruins the quality and the nutritional benefit.
Okay, let's talk about how they convert this fragile liquid into something stable, like a tablet you can buy. This is where the freezing process gets really technical.
Right. This specific process is often called lyophilization or freeze drying. It's really the gold standard for preserving fragile biologicals like this. The RJ is spread in thin layers, then frozen solid at -20 degrees C for at least 12 hours. Then it's placed into a strong vacuum chamber.
And what does the vacuum chamber do?
Instead of melting, the frozen water content actually sublimates. That means it goes directly from solid ice to a gas, completely bypassing the liquid phase. This is crucial because it preserves the structural integrity of all those active ingredients, the proteins and enzymes. What's left behind is a highly concentrated fine powder.
And that powder is then pressed into the final supplement form.
Exactly. That concentrated powder is pressed into small tablets. Typically, you see bottles of 100 or so, and they're packaged in airtight, sterilized containers. Sometimes they even use vacuum sealing or special antioxidation covers, all to ensure absolutely no degradation occurs before it reaches you, the consumer.
Wow. Okay, so we started this deep dive talking about, a simple jar of supermarket honey, and we ended up discussing nomadic logistics coordinating 80,000 colonies. The ingenious deception required to harvest just zero point 0.1 gram of a substance at a time, and factory precision that converts it into a pharmaceutical-grade tablet using advanced freeze drying. It's quite the journey.
It really is. And what's fascinating here, I think, is that delicate balance between these high-tech industrial methods, the centrifuges, the advanced sensors, the specialized freezers, and the ancient, precise craft of beekeeping itself. They've somehow managed to industrialize a deeply natural process while maintaining the absolute integrity of that incredibly fragile product.
You really see the immense effort and the strategic planning required behind every single drop of honey, every single tablet.
Yeah, and it raises an important question, doesn't it? When you really consider the vast labor involved, the seasonal migrations across entire states, the constant monitoring for these existential parasite threats, and the rigorous specialized logistics required just to harvest and preserve this product. How does that change your perception of a simple jar of honey or a royal jelly tablet the next time you see one on the shelf?
That is an excellent thought to end on, something for all of us to think about. Thank you for joining us as we explore the incredible journey of commercial apiculture. We'll catch you on the next deep dive.